Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for the better preparation of your exams. So today, students, we will be solving Andhra Pradesh Engineering, Agriculture and Pharmacy Combined Entrance Test, EAPCET 2023, 19th May, Shift 1 paper. Okay, so in this particular video, I'll be solving the physics part of the paper. So here we go. Starting with the very first question of the physics part, that is question number 81. The potential difference across the ends of a conductor is 50 plus minus 3 volt and the current through it is 5 plus minus 0.1 ampere. The percentage error in the measurement of resistance of the conductor is okay. So first of all, this question is from the chapter of units and measurements. Units and measurements, okay. Now, we know that from Ohm's law, V equals to IR. So, R resistance will be voltage over current. So, for fractional error, del R over R will be equals to what? Del V over V plus del I over I. So, percentage error in R will be equals to del R over R into 100. It will be equals to del V over V into 100 plus del I over I into 100. So del R over R into 100 will be equals to del V over V means this 3 over V 50. So 3 over 50 into 100 plus del I over I means this 0.1 over 5, okay? 0.1 over 5 into 100. So del R over R into 100 will be equals to 5 to the 10, 3 to the 6 plus 5 to the 10, 20. 0.1 into 20 means 2. So it will be equals to 8%. Okay, this is our final answer. So among these four options, option C is the correct answer. Now next question 82. The velocity v of a particle is starting from rest increases linearly with time t as v equals to 40, where v is in meter per second and t is in second. The distance covered by the particle in the first 4 seconds is. So this question is from the chapter of motion in a straight line. Okay. So according to question, we are given with the velocity of particle v equals to 40. So acceleration, we know that A is equals to del V over del T. So for this acceleration will be del by del T of V means 4T. So it will be equals to 4 meter per second square. Okay. So using S equals to UT plus half AT square means second law of motion. This is second equation of motion. Okay. So S equals to UT plus half AT square. Here, the particle starts from rest, means the initial velocity U is equals to 0. Acceleration A comes out to be 4 meter per second square. And T is given as what? 4 second. Okay. So 4 seconds. So solving it, we get S is equals to UT means 0 into 4 plus half AT square means into 4 into T square into 4 square. So it will be half into 4 into 4 4 is 16. So this comes out to be 2 to the 4, 16 to the 32 meters. So our answer is distance is equals to 32 meter, means option B is the correct answer. Now question 83. The time taken by a boat to travel upstream to a certain distance and return back is 14 hours. Okay. If the velocity of boat in still water 35 kilometer per hour and velocity of the stream is 5 kilometer per hour, the distance traveled by the boat before it returns is, okay. This question is again from the chapter of motion in a straight line. Okay, motion in a straight line. According to this question, let us say this is a stream river and the time taken by a boat to travel upstream to a certain distance and return back. Okay, let us say it travels upstream and it return back. Okay, so the time taken by it is 14 hours. Okay, so let v1 be the velocity of boat. Let us say v1 is the velocity of boat. Okay, let us say v2 is velocity of river. Velocity of river. Okay, velocity of boat means, let us say a boat is traveling in this direction, so v1 is the velocity of this boat. Okay, so let the boat travels a distance of x kilometer. Let us say the boat travels a distance of x kilometer, so upstream velocity will be, upstream velocity of boat will become, of boat will become velocity of boat minus velocity of river, v1 minus v2, and for downstream it will be equals to v1 plus v2, means velocity of boat plus velocity of river. So for upstream time, so for upstream time, we know that time is equals to distance over speed, over speed. So for upstream, distance is what? X. And speed is what? V1 minus V2. This is speed. Okay. And for downstream, the time will be, let us say this is T1. Okay. For downstream, the time T2 will be, distance means X over speed is V1 plus V2. Let us say this is equation 1 and this is equation 2. Okay. So here, according to question, T1 plus T2, total time is what? 14 hours according to question. And V1 is 35 kilometer per hour and V2 is 5 kilometer per hour. Okay. So we have to find the value of X. So this adding equation 1 and 2. Adding equation 1 and 2. So T1 plus T2 will be equals to X over V1 minus V2 plus X over V1 plus V2. Now solving it, we get T1 plus T2 is what? 14 hours. It will be equals to X over V1 minus V2, and V1 is 35 minus V2 is 5 plus X over V1 plus V2 means 35 plus 5. Now solving it, we get 14 is equals to X over 30 plus X over 40. So when we solve it, we get X equals to 240 kilometer. This is our required answer. So the distance traveled by the boat before it is 240 kilometers, means option B is the correct answer. Now next question 84. If the angle between two unit vectors A and B is theta, then resultant of A plus B is. So this question is from the chapter of motion in a plane. Motion in a plane. Okay. We are given with two vectors, vector A and vector B. And we have to find the addition of A plus B. Okay. So we know that A plus B, modulus of A plus B is equals to A plus B whole square, means A plus B dot A plus B. So it will be equals to A square plus modulus of A square plus modulus of B square plus 2 A dot B. Okay, and we know that for A dot B, we always dot product, we always use cos theta. And since A and B are what? Unit vectors. So for unit vectors, A square equals to 1 and B square is equals to 1, means 1 square. So it will be equals to A plus B whole square will be equals to 1 square plus 1 square plus 2 1 dot 1 cos theta, because for dot product we always use cos theta term. So sorry, so modulus of A plus B whole square will be equals to 1 plus 1 2 plus 2 cos theta. So it will be equals to 2 1 plus cos theta. So it will be equals to 2 into 2 cos square theta by 2, since we will use the property that is 1 plus cos theta equals to 2 cos square theta by 2. This is the formula. Okay, so we get A plus B whole square equals to 4 cos square theta by 2, means A plus B is equals to 2 cos theta by 2. So among these four options, option A is the correct answer. Okay. Now next question 85. A body of mass 2 kg is on an inclined plane of inclination 30 degree and coefficient of friction is 1 by root 3. The minimum force required to move the body up the inclined plane. Okay. So this question is from the chapter of laws of motion. So let us try to understand this question as, let us say this is an inclined plane. This is a body whose mass is 2 kg. Okay, this is on an inclined plane and the inclination angle theta is given as 30 degree. Okay, so mg sine theta will act in downward direction. This is F frictional force. Okay, and this is force F acting on this body. Okay, so the force required will be equals to F minimum force will be mg sine theta plus this frictional force F. So it will be equals to mg sine theta plus F frictional force means mu mg cos theta. Okay, so it will be equals to mg sine theta plus mu cos theta. Okay, so it will be equals to m is what? 2 kg. So 2 into gravity 10 into sine theta plus mu cos theta. So sine of 30 degree plus mu. Mu is given as this 1 by root 3. 1 by root 3 cos of 30 degree. Okay. So solving it, we get 2 into 10 sine 30 means 1 by 2 plus this 1 by root 3 into cos 30 means root 3 by 2. So solving it, we get 20 Newton force, means the minimum force will be 20 Newton. So option C is the correct answer. Now next question 86. The maximum acceleration with which a body of mass 200 kg is lowered into a well using a rope having a braking force of 50 kg, what is? Okay, so this question is from the chapter of motion in a straight line. Motion in a straight line. Okay, now according to this question, a body is moving in downward direction. Let us say this is a body. This body is moving in downward direction having mass m, let us say. So downward force will be mg force, and force F equals to mass into acceleration, means mg is acting in downward direction and tension force T is acting in upward direction. Okay, so net force F net will be equals to this mg downward direction force minus this upward tension force. So this F is mass into acceleration. It will be equals to this mg minus T. So this T is equals to mg minus ma, taking m common, g minus a. So T maximum will be equals to this mass. Mass is given as what? 200. Okay. And acceleration due to gravity is 10 meter per second square. Okay. So putting these values, and braking force is 50 kg watt. Okay. So putting these values, we get this G minus A. Okay. So it will be 200 into 10 minus A acceleration. Okay. And this T maximum, first of all, write this T maximum. This T maximum will be equals to 50, this 50 kg weight into 10 gravity. Okay. So it will be equals to 500. So in place of T maximum, we write 500 is equals to 200. 10 minus a, so this 0 0 0 0 cancels, so 10 minus a is equals to 5 by 2, so a will be equals to 10 minus 5 by 2 means 20 minus 5 over 2, it will be 15 by 2 means acceleration is equals to 7.5 meter per second square. This is our final answer. Okay. So the answer is 7.5 per meter square means option A is the correct answer. Now question 87. A toy of mass 20 gram at rest acquires a velocity 3 iota cap minus 2 j cap meter per second in 2 seconds. Then the power of the toy. Okay, we have to find the power. So this question is from the chapter of work, energy and power. Okay. So we know that power is equals to what? Work done by the force over time. Over time. Okay. So work done means change in kinetic energy, as we all know, over time. And kinetic energy is what? Half mv square over this time t. Okay. This is power formula. Okay. Let us say this is equation 1. Okay. Now, as object is initially at rest, so change in kinetic energy will be half mv square. So for this, power will be equals to half into m. M is given as 20 gram, means 20 over 1000. It will be converted into kg into v square. Velocity is given as 3 iota cap minus 2 j cap, means 3 iota minus 2 j cap whole square. Okay. Over time. Time is given as 2 seconds. Okay. Just put t equals to 2. Now solving it, we get this 20 plus taking its magnitude 9 plus 4 over this 4000. Okay. So it will be equals to 13 over 200. So we get power is equals to 6.5 over 100 means 0.065 watt. This is our final answer. So our correct option is option D. Now next question 88. A ball is dropped from some height and after first collision with the ground, if it reaches 3 by 4th of its original height, then the percentage loss of its energy. Okay. So again, this question is from the chapter of work, energy and power. Okay. We have to find the percentage loss of its energy. Okay. So let us say initially the ball is at height h. Okay. Let us say initially the ball is at height h. Okay. Then initial energy of the ball will be, let us say, I, and final energy when it reaches 3 by 4th of its original height. 3 by 4th of original height. Okay. So energy will be equals to what? Mg into h, means 3 by 4 into h. This energy is what? Potential energy, na? So this potential energies will be mgh, and it, according to question, it reaches 3 by 4th of its original height. If original height is h, so it will reach 3 by 4th of its original height. So now the energy will become mg into h, means 3 by 4 of h. Okay. So percentage loss of its energy means percentage loss of energy means original energy means initial energy minus the final energy over original energy into 100. Okay, original minus final over original into 100. So it will be equals to 1 by 4 into 100 means 25%. This is our answer. So our correct option is option A. Now next question 89. A solid sphere of mass 2 kg is rolling without slipping on a horizontal surface with a velocity of 5 meter per second. The rotational kinetic energy of the sphere is okay. So first of all, this question is from the chapter of system of particles and rotational motion. Particles and rotational motion. Okay. Rotational motion. Now, the question is saying that there is a solid sphere and its mass is 2 kg. It is rolling, okay, without sleeping on a horizontal surface with a velocity of 5 meter per second. Okay, the rotational kinetic energy will be, okay, since the velocity of rolling body at the bottom of the inclined plane will be v is equals to under root of 2gh over 1 plus k square over r square. Okay, this is the standard formula for finding the velocity of a particle which is rolling over the horizontal surface. And here this k is what? K is the radius of gyration. Okay, so for solid sphere this ratio k square over r square is what? 2 over 5. This is, we all know, for a solid sphere the ratio of this k square over r square is 2 by 5. And for a solid cylinder, this is for solid sphere, and let us say if we deal about solid cylinder, so this value is 1 by 2. Okay, solid cylinder. Okay, so when this solid sphere it rolls on this horizontal surface without slipping, so when this acts like a solid cylinder. Okay, so for v sphere over v cylinder will be equals to under root of 2gh over 1 plus k square over r square. This is for sphere, and into, multiply this with 1 plus k square over r square for cylinder over 2gh. Okay, so it will be equals to under root of 1 plus 1 by 2 over 1 plus 2 over 5. So it will be equals to under root of 3 by 2 over under root of 7 by 5. It will be equals to under root 15 ratio under root 14. So our answer is under root 15 over under root 14. So the next question is 89. A solid sphere of mass 2 kg is rolling without slipping on a horizontal surface with velocity 5 meter per second. The rotational kinetic energy of sphere is. So this question is from the chapter of system of particles and rotational motion. Particles and rotational motion. Okay, rotational motion. Now we are given with mass m equals to 2 kg and velocity v equals to 5 meter per second, and we have to find the rotational kinetic energy of a sphere. So rotational kinetic energy will be equals to what? Half I omega square, where I is the moment of inertia, and for a sphere we know that the moment of inertia I is equals to 2 by 5 mr square. So it will be equals to 1 by 2 into 2 by 5 mr square into omega square, since we know that v equals to omega into r. So omega will be equals to v over r. Just put the value of omega here. So v square over r square. So this r square cancels, 2 cancels. So rotational kinetic energy will be equals to 1 over 5 m v square. Since mass is given as 2 kg and v is 5 meter per second, so it will be 1 by 5 into 2 into 5 square. So it will be this 5, 1 power cancels. So rotational kinetic energy is 10 joule. So from among these four option C is the correct answer. Okay. Now next question 90. A solid sphere and a solid cylinder roll down without slipping along an inclined plane. If they start from rest from the top of the inclined plane, the ratio of the velocities of the solid sphere and solid cylinder when they reach the bottom of the inclined plane is okay. So first of all, this question is from the chapter of system of particle and rotational motion again. System of particles and rotational motion. Okay, rotational motion. Now, as given in the question, there is a solid sphere and a solid cylinder, and there is an inclined plane. These sphere and this solid cylinder, they are rolling down in an inclined plane without sleeping. Okay, if they start from rest, they are starting from rest. So from the top of the inclined plane, we have to find the ratio of the velocities of the solid sphere, means velocity of sphere to the velocity of cylinder. We have to find this value. Okay, when they reach the bottom of the inclined plane here. Okay, so first of all, the velocity of the rolling body at the bottom of the inclined plane, its formula is given as v is equals to under root of 2gh over 1 plus k square over r square, and this k is here radius of gyration. Okay, radius of gyration. So this k square over r square is equals to 2 by 5 for solid sphere, and we know that this ratio k square over r square equals to 1 by 2 for solid cylinder. Okay, now just put the values for sphere and cylinder in this v velocity. So we get v sphere over v cylinder is equals to under root of 2gh over 1 plus k square over r square. This is for sphere into 1 plus k square over r square for cylinder over 2gh. Okay, now put the values in this. We get v sphere over v cylinder is equals to what? Under root of this 2gh cancels, so we get 1 plus 1 by 2 over 1 plus 2 by 5. So we get under root of 3 by 2 over under root of 7 by 5. It will be equals to under root 15 ratio under root 14. This is our final answer. So for among these four options, option D is the correct answer. Okay. So next question 91. A pendulum of time period 1 second is losing its mechanical energy due to damping. Its mechanical energy at time t equals to 0 second is 45 joule. After completing 15 oscillations, its mechanical energy is 15 joule. The ratio of the damping constant and the mass of the object making damping oscillations is okay. So this question is from the chapter of oscillations itself. In the question, we are asked to find the ratio of damping constant, means B over mass of the object, means M. We have to find the ratio of B over M. So first of all, whenever there are damped oscillations, their graph is like something like this. Like these here in x-axis there is time and in y-axis there is energy. So if this represents the energy E naught, so this graph represents the energy of the oscillations, means E equals to E naught e to the power minus gamma t. These are of damped oscillations where E naught is the amplitude, and e to the power minus gamma t, where gamma is the ratio of this damping constant to the mass of the object, which makes the damped oscillations. Okay. So for this type of question, first of all, the energy statement is given as E equals to E naught e to the power minus gamma t, where this E naught is equals to 1 by 2 K A square into e to the power Ka square into e to the power minus b by m into t. Okay. So from the questions, we are given that at t equals to 0 second, the energy E is given as 45 joule, and when time t equals to 15 second, the energy is given as 15 joule. Okay. So using these two conditions given in the question, we write energy E as E naught, means it is equals to 45 when time is 0 second, means it is equals to E naught, means this 1 by 2 K square. Okay. In place of E naught, just write 1 by 2 Ka square e to the power minus b by m into t. T is what? 0 second. So it will be 45 is equals to 1 by 2 Ka square. Okay, let us say this is equation number 1. Now, for this second condition, when t equals to 15 second, E equals to 15 joule. So write E is equals to 15 joule for 1 by 2 Ka square e to the power minus b by m into t. T is what? 15 second. Okay. Let us say this is equation second. Now, dividing equation 1 by second. Okay. Dividing equation number 1 by second. So we write 45 over 15. It is equals to this 1 by 2 Ka square over 1 by 2 Ka square into e to the power minus b by m into 15. Okay. Half k square cancels. So we get 45 over 15. It is equals to e to the power plus of b by m into this 15. Okay. So it will be equals to 45 into 3. So it will be 15 3s are 45. So we write b by m into 15. It will be equals to log e base 3. And we know that log 3 is equals to what? 1.098. So we write b over m is equals to 1 over 15 into log e base 3. Okay, this is our final answer. So from these given four options, the option C, that is 1 by 15 log e base 3 per second, is the correct answer. Okay. Now next question 92. Which of the following statement regarding damping force of a damped oscillator is not correct? Okay. So first of all, what is a damping force? A damping force uh, is involved when vibrating motion is restrained. Okay. Damping force is involved whenever there is a vibrating motion or this vibrating motion is restrained. So we say that it is a damping force. For example, let us say alternating electric currents. Okay. Alternating electric currents or noise, we can say, or mechanical oscillations. These are all examples of the damping forces. Okay. From these four statements, the statement number 1, that is damping force depends on the nature of the surrounding medium. This is correct. And the second, damping force is generally proportional to the velocity of body making oscillation. This is also correct. The third one, that is damping force acts in the direction of the velocity of the body. This statement is wrong, as damping force of an oscillator is always opposing the medium. That is, force is always in the opposite direction of the velocity, means force for damping oscillations, it is also always equals to minus b into v, where b is the damping oscillation. So this statement means statement C is the correct one. sorry, incorrect statement. Okay, now D, that is the ratio of damping force and the velocity of the body depends on the size and shape of the body. This is also correct. So among these four option C is the correct answer. Okay, now next question 93. The gravitational potential energy of a system of three masses m, 2m and 3m placed at three vertices of equilateral triangle of side A is. Okay, so this question is from the chapter of gravitation only. Now, according to question, we are given with three masses and these are placed at the three vertices of an equilateral triangle. So let us say this is an equilateral triangle. Let us say here is mass small m, here 2m, and here it is 3m. Okay, so we have to find the gravitational potential energy of the system. So the gravitational potential energy of the system, it will be U is equals to, let us say this is 1, 2 and 3. So potential energy between 1 and 2 plus potential energy between 2 and 3 and plus potential energy between 1 and 3. Okay, so it will be equals to, as we know that the potential energy is what, gmm over r, minus of gmm over r. So we write the total potential energy of this entire system will be minus of g between these two, 1 and 2. So gm into 2m over the side is of size a. So this will be a over a. Okay, plus it will be minus of g 2m and 3m, or we can write 1 3 na. So m into 3m, m into 3m over a plus minus of g this 2m into 3m over a. Okay, now solving it, we get u total potential energy will be minus of g m square over a into 2 plus 3 plus 6. So it will be equals to minus 639 plus 2 11 minus 11 gm square over a. So this is our final answer, that is minus 11 gm square over a. So among these four option C, that is minus 11 gm square over a, is the correct answer. Now next question 94. A metal wire with circular cross section and length 1 meter is pulled with tensile force of 1000 Newton on each side. Okay, for the wire to be stretched not more than 0.25 centimeter, the minimum diameter of the wire required is. Okay, so this question is from the chapter of mechanical properties of solid. Mechanical properties of solids. Okay, now we are given that the length is of 1 meter. So L is of 1 meter and it is stretched not more than 0.25 centimeter, means the elongation delta L is given as 0.25 centimeter, means it will be 0.25 into 10 to the power minus 2 meter. Okay, we have to find the diameter. So we know that the Young's modulus Y is equals to stress over strain. Okay, so it will be equals to force over area into length over elongation into length. And we know that area is what? Pi r square. But we are asked to find the diameter. So in place of r, we can write pi d by 2 whole square. So it will be pi d square over 4. Okay, in place of area, we write pi d square over 4. So this Young's modulus will be equals to F over delta L into L over area, means pi d square over 4. Okay, now this d square will be equals to what? 4 into 1000, means the force, tensile force which we are given in the question, into 1 over pi into 10 to the power 11 into 0.25 into 10 to the power minus 2 meters. So d square will be equals to 16 over pi into 10 to the power minus 6. So from this we get d is equals to root of 16 over pi into under root of 10 to the power minus 6. So it will be equals to 4 over 1.77 into 10 to the power minus 3, means the diameter will be equals to 2.26 millimeter. This is our final answer. So from these four options, the option B, that is 2.26 millimeter, is the correct answer. Okay. Now next question 95. Two mercury drops of radii small r and 2r merge to form a bigger drop. The surface energy released in the process is, okay. So this question is from the chapter of mechanical properties of fluids. Okay. Now, we are given with two mercury drops, means let us say this is first one having radii small r. This is second one having radii 2r, and they merge to form a bigger drop. Let us say its radius is capital R. Okay. So the volume of the drop will be, volume of larger drop will be equals to the sum of the volume of two these drops is, so it will be equals to 4 by 3 pi capital R cube will be equals to 4 by 3 pi small r cube plus 4 by 3 pi 2r whole cube. Okay. Now this 4 by 3 pi, 4 by 3 pi, 4 by 3 pi cancels. So r cube will be equals to small r cube plus 8r cube, means 9r cube. So capital R will be equals to small r into 9 to the power 1 by 3. Okay, let us say this is equation number 1. Okay. Now change in surface area will be change in surface area. Okay. It will be equals to delta A, means the sum of the surface area of these two drops minus the surface area of the bigger drop. So it will be equals to 4 pi r square plus 4 pi 2r square minus 4 pi into capital R square, and capital R is what? R into 9 to the power 1 by 3, means R into 9 to the power 1 by 3 whole square. Okay, this will be whole square. Now solving it, we get it will be equals to 4 pi r square taking common, so 5 minus 4.326. So it will be equals to 2.7 pi r square. Okay. So in this question, we are asked to find the surface energy released in the process. So surface energy released, it will be equals to surface energy will be equals to surface tension into area. Okay. Into change in area delta A. So it will be equals to 2.7 pi r square into surface tension S. Okay. So our correct answer is option D, 2.7 pi r square S. Now next question 96. The temperature of the earth without greenhouse effect will be. So this is the very common and very basic question asked. Its direct answer is minus 18 degrees Celsius. Okay. This is a direct question. We do not need to solve any question here or solve any long algorithm. Just the correct answer is minus 18 degrees Celsius. Now next question 97. The change in internal energy when 20 gram of a gas is heated from 25 degree Celsius to 35 degrees Celsius at constant volume is. Okay. So this question is from the chapter of kinetic theory. So we have to find the change in internal energy at constant volume. So change in internal energy will be change in internal energy. It will be equals to kinetic energy of the molecule. Okay. Kinetic energy of molecule. Sorry, this change in internal energy of the gas at at constant volume, na? So at constant volume, sorry. At constant volume, it will be equals to delta U, means M Cp delta T. Okay. So it will be equals to 20. Mass is given as 20 gram. The 20 into specific at constant volume is 0.02, sorry, 0.2. So it will be Cp will be 0.2 into delta T. Delta T is what? 35 degrees Celsius minus 25 degrees Celsius. So it will be equals to 20 into 0.2 into 10 into 4.2, okay, joule. Since it will be 4200 joule per kilo Kelvin, na, so it will be 10 into 4.2 joule. So its correct answer is 168 joule. Okay, this is our final answer. So among these four, the correct answer is option D. Now next question 98. A gas of mass m and molecular weight capital M is flowing in an insulated tube with a velocity 2v. If the flow of gas is suddenly stopped and all kinetic energy is utilized to compress the gas, the increase in temperature of the gas is, okay. So this question is again from the chapter of kinetic theory. So the increase of the temperature means here the first of all the change in kinetic energy will be the change in internal energy will be the kinetic energy of the molecule. So kinetic energy of the molecule will be NCV delta T, means it will be equals to half mCV square, means V is 2V whole square, as velocity is given as 2 capital V na in the question itself. The change in internal energy will be equals to the kinetic energy, means change in internal energy will be equals to the kinetic energy of the molecule. So it will be equals to N, and Cv is what? R over gamma minus 1 into delta T. It will be equals to half Nm into 4V square. So this N cancels. So Nm, it will be equals to Nm, okay. Now delta T will be equals to 2mv square gamma minus 1 over R, okay. This is our final answer. Now next question 99. Adiabatic bulk modulus of a gas at pressure P is, okay. So this question is from the chapter of mechanical properties of solids. Properties of solids, okay. We know that the adiabatic bulk modulus of a gas is B. It is equals to minus of gamma into P. So its answer is option B. Now next question 100. In the given pressure P, absolute temperature T, graph of an ideal gas, the relation between volumes V1, V2, V3 and V4 is, since it is a pressure temperature graph. Okay, first of all, this is from the chapter of thermal properties of matter. Okay, it is a pressure temperature graph. So for pressure temperature graph, P is directly proportional to T, means PV, it is equals to nRT. So P will be equals to nR over capital V into T. Okay, so the slope will be directly proportional to nR over capital V, means larger will be the slope, smaller will be the volume, okay. So from this graph, the greatest slope is of V1, then V2, then V3, then V4. So the smallest volume will be is of V1, then V2, then V3, then V4. So option D is the correct answer, okay.
So the next question is 101. The question is asking about the during the propagation of a longitudinal wave in the region of compressions and rarefaction. So first of all, this question is from the chapter of waves, and it is asking about the longitudinal wave. So first we should know what are the longitudinal waves. So longitudinal waves are the waves in which the vibration of the medium is parallel to the direction of the wave travels and displacement of the medium is in same direction of the wave propagation, okay. So these mechanical longitudinal waves, these are also called compression waves. Okay. So in this question, we are asked to find the propagation of the waves in the region of compression. So compressions are formed when the different layers, or we can say the molecules, come close, and similarly in rare fraction they move apart. Okay. So there is more density in compression than as compared to rarefaction. So given these four options, the option A, that is density varies in the region of compression and rarefaction, is the correct answer. So option A is the correct option. Okay. Now moving towards the next question, 102. The question is, with respect to air, the critical angle in a medium for red light of wavelength lambda 1 is theta. Other effects remaining same, critical angle for yellow light of wavelength lambda 2 will be. Okay. So this question is from the chapter of ray optics, and it is asking about the uh, factors that are responsible for the critical angle for yellow light of wavelength lambda 2. Okay. So at as critical angle of medium IC and refractive index N are related, as we know that from the Snell's law, sin IC, that is critical angle, is equals to 1 over N, where IC is the critical angle and N is the refractive index. Okay. Refractive index. So we know that from these light, the refractive index of violet color is greater than the refractive index of yellow color, and it is greater than the refractive index of red color. Okay. So since this is the inversely proportional to, means the critical angle, sign of critical angle is inversely proportional to the refractive index. So from these we can say that the critical angle for violet color is less than the critical angle for yellow color, and it is less than the critical angle for red color. So our correct answer is option C, less than theta. Okay. Now, next question, 103. In a Young's double slit experiment, a laser light of wavelength 560 nanometer produces an interference pattern with consecutive bright fringes separation of 7.2 millimeter. Now, another light is used to produce an interference pattern with consecutive bright fringes separation of 8.1 millimeter. The wavelength of second light is okay. So we have to find the wavelength of second light, means this question belongs to the chapter of wave optics. First of all, we should know what is an interference pattern and what are the consecutive dark and bright fringes. So what happened in an interference pattern? First of all, there is an coherent source. Okay, let us say this is a coherent source. To form the interference pattern, the source must be coherent always. Okay, so there is a slit. Let us say there are two slits. This is slit S1, this is slit S2. When the light rays passes through these slit, they form different wavefronts. Okay, the light waves that are passing through S1, it is also forming wavefront in this pattern, and another slit S2 forming a wavefront in this pattern. Okay, when these wavefronts they interfere, this is a screen, so they form different kinds of bands which we call fringes. So these fringes are of alternate dark and bright fringes. The center one, that is the fringe which is along this direction, this is having the maximum intensity. So we says that this is the central maximum bright fringe. Okay, so this happens in an interference pattern, and it is in this question we are given the um, wavelength 560 nanometer, means the coherent light that is coming from this coherent source, it is its wavelength is given as 560 nanometer. And the consecutive bright fringes, means let us say this one is bright, so this one will be dark, another bright, another dark. So according to question, the consecutive bright fringes, they having a separation of 7.2 millimeter, and another light is coming, let us say there is another coherent source and light is coming from it, and there are forming an interference pattern with consecutive bright fringes of separation 8.1 millimeter. Okay, when the wavelength is 560 nanometer, then at the time the separation is 7.2 millimeter. Okay, and when the wavelength is, we have to find the wavelength when the separation is 8.1 millimeter. Okay, so we have to find this wavelength lambda for another light that is forming an interference pattern. So from in Young's double slit experiment, the formula for the fringe width, okay, the formula for fringe width is what? It is beta is equals to lambda d over d, where capital D is the distance between the slit and the screen, and small d is the distance, means width of the slits. Okay, so from this, this for this type of question, this d, capital D, and this small d are constant, so beta basically depends on what? Wavelength lambda. So from this we can say that beta 1 over beta 2 is equals to lambda 1 over lambda 2. Okay, so we can write beta 1 over lambda 1, it is equals to beta 2 over lambda 2. Since we have to find the wavelength lambda 2 for the second light that is forming another interference pattern, so we can write lambda 2 is equals to beta 2 over beta 1 into lambda 1. And we are given beta 2 is what? 8.1 millimeter, beta 1 is 7.2 millimeter, and lambda 1 is 560 nanometer. So solving it, we get lambda 2 is 630 nanometer. Okay, this is our final answer. So among these four options, the option B, that is 630 nanometer, is the correct answer. Now moving towards the next question, that is 104. Uniformly charged conducting sphere of 2.4 meter diameter has a surface charge density of 80.0 microcoulomb per meter square. The charge on the sphere is nearly. Okay, so this question is from the chapter of electric charges and field. Electric charges and fields. So in this question, we are given a conducting sphere. Conducting sphere means inside the sphere, the electric field is zero. All the charge resides only on the surface of the sphere. Okay. This condition is similar for conducting sphere, for spherical shell, and as well as for hollow sphere. Uh, okay. In these three type of sphere, that is conducting sphere, spherical shell, and hollow sphere, always the electric field is zero inside these type of spheres, and the charge always resides only on the surface of the sphere. Okay, so according to question, we are given surface charge density as sigma is equals to q over area. Area is what? 4 pi r square for a sphere. Okay, so we have to find what? We have to find the charge. Okay, so from this charge, q is equals to sigma surface charge density into area, 4 pi r square. So sigma is given as 80 microcoulomb, means 10 to the power minus 6 into 4 pi into r. Radius is given as 2.4 meter. Okay, so 2.4 whole square. Sorry, 2.4 is the diameter. Okay, so 2.4 divided by 2 whole square. So it will be 1.45 into 10 to the power minus 3 coulomb. Okay, so the charge of this conducting sphere will be 1.45 into 10 to the power minus 3 coulomb. It means options B is the correct answer. Now next question, 105. Two charges that are plus q and minus q, each of 1 microcoulomb, are arranged as shown in the figure. If the x is equals to 2 centimeter and y is 3 centimeter, then the potential difference between VA and VB is, okay, VA minus VB, okay. So this question is from the chapter of electrostatic potential and capacitance. Electrostatic potential and capacitance. So we have to find the potential difference between VA and VB, okay. So system of the charges given in the question, it will be like this is plus Q charge. So this is point A, this is point B, and this is minus Q charge, okay. So this is according to question 2 centimeter. This is 3 centimeter and this is again 2 centimeter, and we have to find the potential difference between this point A and point B. We know that the formula for the potential is equals to what? 1 over 4 pi epsilon naught Q over R, and taking this term as constant, let us say K, so we can write V is equals to KQ over R, okay. Now, since VA will be this constant term 1 over 4 pi epsilon naught is equals to 9 into 10 to the power 9. So we can write 9 into 10 to the power 9 into charge 1 into 10 to the power minus 6 over R is what? 2 into 10 to the power minus 2 meter, okay? And plus since it is minus 9 into 10 to the power 9 into 1 into 10 to the power minus 6 over 5 into 10 to the power minus 2 meter. Since this A and B, we have to find the potential difference between this A and B, na? So for A, we will use this positive charge plus Q, and it is having a distance of 2 centimeter. And if we want to find the potential difference between for this B point, means we have to take this 3 plus 2, okay? So it will be, sorry, for this A only, for this A, it will be 3 plus 2 from this negative charge. From this positive charge, it is of 2 centimeter, and from this negative charge, it is of 3 plus 2, 5 centimeter. So VA will be equals to what? Taking 9 into 10 to the power 9 common into 10 to the power minus 6 over 10 to the power minus 2 common. So we will get 1 by 2 minus 1 by 5. Okay, so it will be 227 into 10 to the power plus 4 volt. This is VA. Let us say this is equation number 1. Now solving for a potential at point B. So VB will be equals to the distance of point B from this positive charge is what? 3 plus 2, 5 centimeter. Na? So it will be 9 into 10 to the power 9 into 1 into 10 to the power minus 6 over 5 into 10 to the power minus 2 meter. And from this negative charge, it is of 2 centimeters. So plus minus of 9 into 10 to the power 9 into 1 into 10 to the power minus 6 over 2 into 10 to the power minus 2 meter. To solving it, we get VB is equals to 9 into 10 to the power 9 into 10 to the power minus 6 over 10 to the power minus 2, taking this part common. So we get 1 over 5 minus 1 over 2. It will be minus of 27 into 10 to the power 4 volt. Let us say this is equation number 2. So VA minus VB, since in this question we are asked to find the potential difference between point A and point B. So potential difference, it will be VA minus VB delta V. So it will be 5.4 into 10 to the power 5 volts. So this is our desired answer. So among these four options, option B, that is 5.4 into 10 to the power 5 volt is the correct answer. Now, next question 106. Two identical capacitors A and B are connected as shown in the circuit. Initially, the switch S is closed. Now the switch is opened and free space between the plates of the capacitors is filled with a dielectric of dielectric constant 3. The ratio of the total electrostatic energy stored in the capacitors before and after introduction of the dielectric is, okay. So this question is again from the chapter of electrostatic potential and capacitance. Electrostatic potential and capacitance. Okay, now in this question, we have to find the ratio of the electrostatic energy is stored in the capacitors before and after. Okay, so we know that the formula for energy of the capacitor is what? Energy of capacitor is equals to 1 by 2 CV square. Okay, so the first condition is that when the switch is opened. Okay, so when switch is open, that is Q on second capacitor will be CV. The formula for charge of a capacitor is what? C into V, capacitance into voltage. So this charge Q for the second capacitor, this is 1, this is 2. For the second capacitor will be this Q equals to CV. And after introduction of the dielectric, Q remains same. Okay. So, but C will become K into C. Okay. When a dielectric is introduced. When a dielectric is introduced, we know that the charge always remains same, whether we remove the dielectric or we insert any dielectric, the charge always remain the same. So for this also the charge will remains the same, but the capacitance C will be changed. It will be K into C. This K is the dielectric constant. Okay. Let us say this is condition 1, this is condition 2. Okay. Now the energy will become, energy is equals to Q square over 2C, and this Q square over 2C. C will be K1. Okay. So Q, if we know that Q is equals to C into V, so it will be CV square over 2 into, let us say K1 is the first dielectric constant. So it will be, acha, in place of C, we will write K into C. Okay. Since we have introduced a dielectric now, so we, in place of C we will write K into C, so it will become C square V square over 2KC. So this C cancels one power, so for this we get energy is equals to CV square over 2K. Okay, let us say this is equation 3. So energy will be, we know that it is half CV square. Okay, now when the same for, we will do this for before after a dielectric in insertion C became Kc. Okay, so for this energy will be equals to half, in place of C we will write K into C into V square, so it will be it will become half K into CV square. Okay, let us say this is equation 4. Now the total energy will become, total energy initially will be, means before the introduction of dielectric, means without K value. Okay, so it will be half CV square plus half CV square for the two capacitors. This is for capacitor 1, this is for 2. It will be CV square, let us say this is equation 5. So total energy will be, total energy after opening the switch, opening the switch, it will be this KCV square over 2 plus CV square over 2 into K. Means we have add this equation 3 and equation 4. Okay, where after the introduction of the dielectric, so it will become CV square over 2, this K plus 1 by K. Okay, now in this question, we are given the dielectric constant K equals to 3. So just put the value of K equals to 3. We get CV square over 2 into 3 plus 1 by 3. So it will become CV square over 2, 3 3 is a 9 plus 1 over 3. So it will be equals to CV square over 6 into 9 plus 1, 10. Okay. So it will be equals to 2 3s are 6, 2 5s are 10. So 5 CV square over 3. Okay, let us say this is equation number 6. So now dividing equation 5 by equation 6, we get dividing equation 5 by 6. So we get 5 fifth equation is what? CV square, and sixth equation is 5 by 3 CV square. So this CV square cancel. We get 3 over 5 means we get the ratio of this electrostatic energy stored in the capacitor before and after the introduction of the dielectric. So our correct answer is option C, 3 ratio 5. Okay. Now, next question 107. The resultant resistance between A and B in the figure is, okay. So this question is from the chapter of current electricity. Okay. We have to find the resultant resistance between point A and point B. Okay, we can modify, or we can rearrange this figure as, let us say, this is point A. So this will be of 3 ohm. This is another 3 ohm, and this is 6 ohm between A and C. So this will be point C, and this is 3 ohm, and this will be, let us say, this is point A. Let us say this is point B, and this is again 3 ohm. Okay. So modifying this, so we redraw this circuit as, again redrawing this circuit, so we get this is point D. Okay. Again redrawing this circuit, so we can write this is point A. So this will be 3 ohm. This is point B, and solving these, this is 0.3 ohm. Okay. Because these equivalent means 3 ohm, 3 ohm, and this 6 ohm will become equivalent resistance of 3 ohm. Okay. Now, again, this can be A, B. This will be again 3 ohm. This is 3 ohm. So in place of these 3 ohm, 3 ohm, 6 ohm, we are writing this 3 ohm. Okay. So again, now solving this pattern, this circuit, we get this is point A, this is 3 ohm, this is point B. To solving this, because since these are connected in series, so we can write 6 ohm here. Okay. Now these 6 ohm and 3 ohm, they are connected in parallel. So we write resistance between A and B is equals to 6 into 3 over 6 plus 3. 6 3s are 18, 6 plus 3, 9, 9 2s are 18. So our final resistance is 2 ohm. Okay. Once again, I'm explaining this question again. So this is point A, this is point B, this is point D, and this is point C. We have asked to find the resultant resistance between point A and point B. So we redraw this circuit as, let us say this is point A, and this A and D means this 3 ohm is this. Okay. This 6 ohm between A and C is this, and these 3 ohms, these are this and this. Okay. And this 3 ohm is here. Okay. Between D and C means this one. Okay. Now for these 3 ohm, 3 ohm and 6 ohm, we write their equivalent as this 3 ohm. Okay. Now these three equivalent of these 6 ohm, 3 ohm, 3 ohm is this 3 ohm. This is again the original one, 3 ohm, and this is 3 ohm.
these 3 ohm and 3 ohm, they are connected in series, so their equivalent is this 6 ohm, and this is again 3 ohm. These two are connected in parallel, so solving this for parallel combination, we get the final answer, means the resultant resistance between point A and B as 2 ohm. Okay, so among these four option B, that is 2 ohm, is the correct answer. Now next question, 108. In the circuit, E1 equals to E2 equals to E3 given as 2 ohm, okay, and R1, R2 are given as 4 ohm. So we have to find the current flowing through E2. Okay, we have to find this current E2, that is between point A and B. So this question is again from the chapter of current electricity. Now, E1 is what? E1 is given as 2 volt, and this R1 is given as 4 ohm, and this is point A na. So E2 is given as 2 volt, and this is point B, and this E3 is given as again 2 volt, and this R2 is 4 ohm. Okay, let us say okay, now applying, let us say this is loop A and this is loop B. Okay, now applying Kirchhoff's voltage law loop in this loop A and B. So for Kirchhoff voltage law for loop 1, we can write the current direction will be this I1, this will be I1 plus I2, and this is I2. Okay, so for loop 1 we can write 2 minus 4I1 plus 2, it will be equals to 0. Okay, so from this we can write 4 minus 4I1 equals to 0. So I1 will be equals to 1 ampere. Okay, for loop 2 we can write, loop 2 means loop B, we can write 2 minus 4I2. Okay, this is loop 1 means loop A, this is loop 2 means loop B. So we can write 2 minus 4I2 plus 2 equals to 0. So for this I2 will be 1 ampere. So current through E2, current through E2 will be I1 plus I2, means capital I equals to I1 plus I2, and I1 is 1 ampere, I2 is also 1 ampere, so it is 2 ampere. So our correct answer is 2 ampere, means the option B, that is 2 ampere from A to B, is the correct answer. Okay. So the next question is 109. Among the following ampere circuital law is represented by. Okay, so this question is from the chapter of moving charges and magnetism. Moving charges and magnetism. Okay, so it is asking about the ampere circuital law. So what is ampere circuital law? This law states that the line integral of the magnetic field surrounding any closed loop, this circle represents the closed loop. Okay, so line integral of the magnetic field surrounding any closed loop is equals to number of times the algebraic sum of the current passes through the loop, means it is equals to mu naught times the total current, means this total current will be equal to algebraic sum of the current passing through the loop. So it is equals to mu naught times the total current enclosed by the surface. So this is the ampere circuital law, that is the line integral of the magnetic field surrounding any closed surface is equals to mu naught times the total charge enclosed by the surface. This mu naught is equals to 4 pi into 10 to the power minus 7. Okay, so among these four, the option B is the correct answer. Okay, now next question 110. The radius of the path of an electron moving at a speed of 3.2 into 10 to the power 7 meter per second in a magnetic field of 6 into 10 to the power minus 4 Tesla perpendicular to it is. Okay, so this question is from the chapter of magnetism and matter. magnetism and matter. Okay. In this question, we have to find the radius of the path of an electron which is moving at a speed of 3.2 into 10 to the power 7 meter per second, and the magnetic field is given by this. Okay, so we know that the QVB, it is equals to mv square over r. Okay, so this one power cancels this, so r will be equals to what? Mv over qb. So m mass is given as 9 into 10 to the power minus 31 kg, this mass, and velocity is given as 3.2 into 10 to the power 7 meter per second over charge. Charge is what? Charge of electron is 1.6 into 10 to the power minus 19 into magnetic field. This 6 into 10 to the power minus 4 Tesla. So solving it, we get R is equals to 30 into 10 to the power minus 2 meter. It means it is equals to 30 centimeter. This is our desired answer. So the correct option is option C. Okay. So next question is 111. The magnetic field lines of a bar magnet. Okay. So this question is from the chapter of magnetism and matter again. And we have to find the correct answer among these four options. So it is asking about the magnetic field of a bar magnet. So students, let us say this is a bar magnet, this is North Pole and this is South Pole. So always the magnetic field line passes from South Pole to North Pole inside of a bar magnet, and it always travels from North Pole to South Pole outside of the bar magnet. Okay. So the correct option is option D, that is the magnetic field lines of a bar magnet forms continuous closed loop, means inside the magnet they are traveling from south to north pole, then outside it they are traveling from north to south pole, means they are forming a continuous closed loop. So option D is the correct answer. Now next question 112. The shiny metal disc in the electric power meter analog type rotates due to. Okay. So this question is from the chapter of alternating currents. Okay. Alternating currents. So the we know that the electrical meters works on the principle of the eddy current. So eddy current is the correct answer. Okay. Now next question 113. An AC voltage of 10 sine omega t volt is applied to a pure inductor of inductance 10 Henry. The current through the inductor in ampere is. Okay. So this is again from the chapter of alternating currents. Alternating currents. Okay. So in this question, we are given AC voltage of 10 sine omega t and inductance of 10 Henry. We have to find the current. Okay. So current through the inductor will be current through inductor. It will be equals to I equals to this V naught sine omega t minus pi by 2 over XL, means over impedance. Okay, where impedance XL is equals to L into omega. L is the inductance, and so this will be equals to V naught. V naught is comparing this AC voltage, means we are given with this V naught sine omega t na. So here V naught is what? 10. So putting V naught equals to 10 sine omega t minus pi by 2 over XL is L into omega. L is what? 10 into omega. So it will be equals to this 10, 10 cancels. So we get 1 over omega into sine omega t minus of pi by 2. So our correct answer is option A, that is 1 over omega sine omega t minus pi by 2. Okay. Now next question 114. The electromagnetic waves of energy flux 75 into 10 to the power 4 Weber per meter square incidents normally on the surface of area 40 centimeter square. If the surface absorbs the flux completely, the total momentum delivered to the surface in 1 second is. Okay. So this question is from the chapter of electromagnetic waves. Electromagnetic magnetic waves. Okay. We are given with the electric flux that is 75 into 10 to the power 4 and a surface area of 40 centimeters square. So we have to find the total momentum delivered to the surface per second, means in 1 second. So momentum delivered will be momentum delivered to this surface will be equals to P equals to mu over C. So this momentum will be equals to mu is what? 75 into this U, energy flux, into 10 to the power 4 Weber per meter square, into this surface area 40 centimeter square, means 10 to the power minus 4 meter square. Since see, we have to find this U na, so this U is equals to this energy flux into its area. Okay. So we have write 75 into 10 to the power 4 into 40 into 10 to the power minus 4 meter square over C. C is what? 3 into 10 to the power 8 meter per second. So we get momentum is equals to 10 to the power minus 5 kg meter per second. Okay, this is our final answer. So option D, that is 10 to the power minus 5 kg meter per second, is the correct answer. Now next question 115. The de Broglie wavelength of a charged particle accelerated through a potential difference V is lambda. If the potential difference is increased by 21%, the de Broglie wavelength of the charged particle is. Okay. So this question is from the chapter of atoms. Okay, we all know that de Broglie wavelength lambda is equals to h over p, where h is the Planck's constant and p is the momentum. Okay, and according to this question, for a charged particle, the de Broglie wavelength will be c lambda equals to h over p, and p is what? Mass into velocity. So we can write lambda equals to h over mv. This is velocity na. Okay, in terms of oscillated particle, okay, we have to write in terms of oscillating potential. So those students, the for oscillating potential, the wavelength is always inversely proportional to root of under root v, where v is the accelerating potential. Okay, always remember when we have to write the de Broglie wavelength in terms of the potential, so it is always inversely proportional to under root of that potential V. Okay. Now, according to question, when the potential is increased by 21%, we have to find the de Broglie wavelength. Okay. So this new wavelength lambda dash will be equals to 1 over under root of 21%, na, under root of 21 over 100 into V. It is increased by 21%. Let us say, first of all, it is 100% and it is an increased by 21%, means 100 plus 21, it is 121. So here we write 121. Okay. So 121 over 100 into V. So it will be equals to lambda dash over under root of V is what? Lambda. So in place of only under root of V, we can write lambda. It is equals to 10 over 11. Okay. So lambda dash is equals to 10 lambda over 11. Got it? See, here we write lambda dash is equals to 1 over under root of 121 over 100 into V, means we have written lambda dash equals to 1 over under root of 11 over 10 into under root of V. Okay. And this 1 over under root of V is what? Lambda na. So we can write lambda dash equals to 1 over under root of 11 over 10 into this lambda. So from here we can write lambda dash lambda dash equals to this 10 over 11 into lambda. Okay, 11, 11 is a 121. So in place, this is not under root. Okay, so we can write lambda dash equals to 10 over 11 into lambda. So from this, we get our final answer, that is lambda dash equals to 10 over 11 into lambda. Okay, got it? Now next question 116. The minimum excitation energy of an electron revolving in the first orbit of hydrogen is. Okay. So this question is from the chapter of atoms and nuclei. Okay. So in this question, we are given the first orbit of hydrogen and we have to find the maximum excitation energy. So the excitation energy of the electron in the nth orbit is, we know that nth orbit energy formula is what? Minus 13.6 over n square electron volt. And we have to find in the first orbit. So for first or minimum excitation energy will be minimum excitation energy. It will be equals to what? Minus 3.4 minus 13.6. Okay. So it will be 10.2 electron volt. This minus 3.4 comes since we have to find the minimum excitation. Minimum excitation means from n equals to 1 to n equals to 2. So for if we put the value of n here 2, so we get this energy is equals to minus 13.6 over 4. It will be minus 3.4. And for n equals to 1, we will get minus 13.6. So the minimum will be 2 from 2 to 1. Transition from 2 to 1 means minus 30. This is minus 3.4 and this is minus 13.6. So subtracting minus 13.6 from minus 3.4, we will get the minimum excitation energy, that is 10.2 electron volt. Okay. Now next question. The process that mainly takes place in the star to produce energy. Okay. So this question is from the chapter of nuclei. So in a star, the nuclear fusion process produces the energy. Okay. So for stars, the correct answer is nuclear fusion reaction. Option B. Okay. Now next question 118. In a CE transistor, when the base current increases by 60 microampere, change in the base emitter voltage is 1.2 volt. Then the input resistance is, okay. This question is from the chapter of semiconductor. Okay. In this, we are given that the base current increased by 60 microampere and base emitter voltage is 1.2 volt. So we have to find the input resistance. Okay. We know that delta UBE base emitter is equals to given as 1.2 volt means a change in the base emitter voltage. It is given as VBE equals to 1.2 volt. Okay. So, and delta IB is given as 60 microampere. Change in the base current, na 60 microampere. So, our input will be delta VBE over delta IB from V equals to IR. So we have to find R na. So we write V over I from Ohm's law. So delta VB is what? 1.2 volt and delta IB is 60 microampere. 60 microampere means 60 into 10 to the power minus 6 ampere. So it will be 20,000 ohm. So the correct answer is option D, that is 20,000 ohm. Now next question 119. The photocurrent in a photodiode depends on. Okay. So this question is again from the chapter of semiconductor. So we have to find the correct answer from these four options. So more intense light means a beam is more photons. If a light is more intense means if the light is having maximum intensity or more intensity, so we can say that this light consists of more number of photons. Okay. So the photocurrent is directly proportional to what? The current is directly proportional to intensity. Means maximum intensity means maximum number of photons and maximum number of photons means maximum current. So the photocurrent depends on the directly proportional to the intensity of light provided frequency more than the threshold frequency. Okay. Threshold frequency. So the correct answer is option D. That is, the photo current depends on the intensity of the incident light. Okay. Now next question 120. A message signal of frequency 14 kilohertz is used to modulate a carrier of frequency 900 kilohertz. Then the frequencies of the sidebands are. Okay. This question is from the chapter of communication system. Communication system. So students, we know that there is a direct formula for the sideband frequencies. In communication chapter, the sideband frequencies are found from a direct formula, that is F is equals to what? FC plus minus FM. And here in this question, the FM is given as 14 kilohertz and FC carrier frequency is given as 900 kilohertz. Okay, so just put the values here and we will get our answer. So F will be equals to 900 plus 14 when we take the positive sign. So it will be 914 kilohertz, and F will be equals to 900 minus 14 when we will take the negative sign. So it will be 886 kilohertz. So our correct answer is option C, 914 hertz and 886 kilohertz.